Hello everyone, welcome to the Mammothon tutorials. I hope you're all excited to get started. We're going to start off with a short introduction. So first of all, I wanted to introduce myself. I'm Rebecca, I'm the Programme Manager for the Mammothon from Encode Club. And I'll be in contact with you throughout the programme, and if you have any questions at all, then I'm the person to ask. So just send me a message on Discord or by email, and I'll try my best to help you out in any way that I can. So at Encode Club, we're an education community. We help you learn, build and forge your careers in emerging technology. We do this through educational events like hackathons, public education series, boot camps and accelerators. And we hope those of you who are new and joining us from the Mammothon will stick around in our community as you build and grow, because we're really excited to be part of your journey. So let's talk about the Mammothon. It's a really simple process. You have 28 days to build and ship your projects and be in with a chance of winning part of the $250,000 prize pool. So that is huge. The prize pool is going to be split evenly between the top 10 teams across all idea tracks. Now, this is where the Mammothon is a special event. In the Mammothon, you don't have to come up with your own project concept. There are Celestia Ecosystem partners who have shared ideas on what they want to see built on their tech stack. So they've given you all the resources that you need to succeed. You can build unstoppable apps, you can craft on-chain worlds, and you can upgrade the internet. The last thing to mention about the Mammothon before we move on to the tutorials is that in order to participate, you must be in a team of 3 to 5 devs. If you've not already, please read your emails for information on how to build up your team or how to register the other team members in your team to make sure that you qualify to compete in the Mammothon. When we launch, we'll have over 30 ideas, which means a few more are going to be announced very soon, so keep an eye out for that. And each one comes with a matching tutorial. This is really important. We want to make sure that you have everything you need to start the Mammothon so that you succeed. In these workshops, you're going to get all the essential technical skills that you need, and you're going to have the opportunity to ask questions and clarify requirements with each of the idea partners. Okay, so that is everything from me. Let's jump right in.
Let's basically start talking about what abundance is and what Gelato is. First of all, I'm the co-founder of Gelato, and abundance is the most recent project out of Gelato, which is currently essentially the ABC stack. And the ABC stack is really cool. It's Celestia native. That's also why we're part of this hackathon. And essentially, it is the first EVM stack, rollup stack that has breached the gigagas barrier. And gigagas essentially is a measurement of on-chain compute capacity. I sometimes liken it to gigahertz in the world of Web2 CPUs. And essentially ABC lets you deploy EVM chains on Gelato's Rollup-as-a-Service platform. And these EVM chains are Celestia sovereign rollups. And this is very important to understand. They're not normal Ethereum L2s like we also have at Gelato, for example, with OP Stack or Arbitrum. These are non-Ethereum, non-L2 rollups. They're just sovereign rollups that use Celestia purely for data availability and use your own rollup node for everything else, so execution and settlement. So you can think of them, these rollups, much more like an L1 than an L2 because they're chains by themselves and they don't really refer to a smart contract like client on another chain like normal L2s would. So yeah, that's just a bit of background on ABC. And why should you be excited about this? Why should you use this in the hackathon? Anirudh can shine a lot more light on that later on, but from what little I gathered, essentially we have provisioned a fully fledged, all batteries included ABC Testnet for you guys, a shared testnet, where you'll find a lot of the Gelato utilities. Anirudh will correct me later on, but I'm pretty sure that the basic utilities are deployed there. So you'll have a block explorer, you'll have RPC connection, you'll probably have Gelato relay and Gelato functions. If you're not familiar with Gelato, by the way, we've been around for 5 years, and Gelato specializes in all things developer infrastructure and tooling in Web3. So we started out with automation and serverless. You still have that today. It's called Gelato Functions. and gasless relay APIs that you can also use for account abstraction, 437 style, and even 7702 style. I'm not sure if we enabled that on the testnet yet, but maybe we did, I don't know. Anyways, you can use the 437 style if you want to do it old school. And yeah, so I think my personal take as the founder of all this Abundance and Gelato, what I would be excited on you guys building. I know Anirudh already has some sort of pre-made ideas there, but recently, I think as of last weekend, Anirudh here actually got our PR merged into the ELISA framework. That means that you can now use ELISA OS and use, essentially he integrated Gelato Relay and One Balance into that, which means that now you can use ELISA to build AI agents and you can use Gelato therein to send transactions. Now, Anirudh will have to verify if our testnet for this hackathon is enabled on there yet already. Maybe it is, if you're lucky. And then I think one thing you could really do is essentially use that ELISA plugin that Anirudh built and use the ABC testnet that you have, build a cool AI agent use case with that. You know, usually AI agents are just Twitter bots, right? But, you know, maybe you can build a little game or application that also has an on-chain component that maybe the bot tweets about, or maybe the bot produces AI outputs that can be used as inputs for the application. You know, hint, hint, there's also something called Gelato VRF. Maybe you can build a little game with that. So yeah, that would be my 2 cents. Now, ABC is really cool because it's Celestia native. So using the testnet alone is cool, but if you really want to show the beauty of ABC, you should hammer it with transactions, and you should really try to breach that gigagas barrier. So I'm not sure if you guys are aware, but there is this page called gigagas.live. I will quickly show you the page. 1 second. There we go. Yeah. So Anirudh, can you quickly nod your head if you can see it?
Yeah.
Cool.
All good.
Nice. So here you can track gigagas. So it's gigagas.live. And as you can see, there's already one ABC testnet that we had running for like 3 months. And usually it sits around like close to the gigagas or sometimes even over the gigagas barrier. As you can see here, how it compares to the other networks like Base and so on. So it's like a, you know, multiple order of magnitude improvement in terms of throughput over these other chains like Parachain Testnet and so on. So maybe we also have a way to get our hackathon, our dedicated testnet for the hackathon on here. Anirudh, I'm sure you can talk to someone inside Gelato to get that done. And yeah, would be cool if the use cases that you're building on this testnet that Anirudh has commissioned for you, if they are like really, you know, trying to get close to that gigagas barrier at the end of the testnet, at the end of the hackathon. That would be cool. So obviously an AI agent bot use case is great because normally the way to get a lot of on-chain usage is by using bots, right? So yeah, that's my 2 cents here. I think I already spoke way too long, so I'm gonna stop here and give the stage to Anirudh. Thank you very much. Looking forward to what you guys will be building.
Thank you so much, Lewis. Sure, I can go ahead and share my screen now. Cool. I think the screen should be visible. So, all right.
Yes, we can see it.
I think. Cool. Thank you so much, Lewis. Yep. So let's get started. Hi, everyone. My name is Anirudh. I do developer relations here at Gelato. And for today, we'll be going over the ideas that we have for you guys for this hackathon. So essentially, I'll be walking you through what, how you can connect to the chain, how you can use Gelato Relay, how you can use Web3 functions. Also, we'll be diving a little bit deep, not really a little bit deep, but I'll also be giving you some sort of onboarding to like what Lewis said, the ELISA OS, maybe showing you some screenshots of what we built and how you can essentially use ELISA OS with Gelato Relay, which is the plugin that we built. So yeah, let's get started. So the first idea for the project that we have is creating a video NFT DEX on the ABC stack, on the ABC public testnet. So let's give a bit of context about how this works and what the idea essentially is. So if you think about it, it's kind of like the TikTok mixed with friend.tech. So what you can think of it is like it's a short form video content where each TikTok video or each video could be minted as an NFT, and this would allow creators to essentially sell, and then fans can essentially buy, trade, or sell on the platform itself. So there could be a marketplace where the fans could be able to do that. And for every, let's say, every secondary sale, this would allow creators to get a percentage of royalty, for example. So that's like the gist of the idea. If you would like to take a look as an example of what this could look like, I think something close would be called Dracula.app. I think that essentially allows you to. It's a platform where you can essentially have videos. It's a Web3 version of TikTok as well. I think under the hood they're using Gelato Relay as well for I think some sort of minting they're doing on their end. But yeah, I think that's like the gist of idea. I'll be diving a little bit deep more into the idea itself now. So as mentioned, the concept, it's a decentralized platform where users upload videos, tokenize them into NFTs, and trade them seamlessly. And this combines the appeal of short form videos platform like TikTok with the blockchain capabilities that, like, for example, the ABC public testnet, and also allows for monetization capabilities. Now, I'll be diving a little bit deeper into the core features. So just so you have an idea of how to implement. So basically, I have thought in such a way that you can understand this even though you're like coming from a really starting like as a beginner, because let's be honest, even I started hackathon as a completely beginner, and I think it's good that everyone's able to understand what's going on. So I'll also be walking you with a bit of the architecture if you have time. But yeah, so the core features include the video tokenization. So users should be able to upload videos and mint them as, let's say, ERC-721 tokens, also called as NFTs. And the NFT metadata could include the video link, the title, as well as the royalties. Then we could have, for the videos itself, we could have the decentralized stores. For example, they could be stored on IPFS. An example I could think of from top of my head would be Web3.storage or maybe NFT.storage, for example. Next up, there's also the marketplace where users can list, trade, or auction for the video NFTs. There's also going to be social interaction on this platform, so users can follow creators, like, share, and engage with the DEX as well. And lastly, there's going to be creator royalties. Example, for every secondary sale, there's going to be some sort of percentage that the creators get for every sale of the NFT, for example. So yep, here's how the end-to-end workflow looks. So users will user will upload a video. The smart contracts generate the metadata, and asset is stored, and NFT is minted. This is where you can use gasless transactions and use Gelato Relay for minting it. Next, there is the listing where NFT is listed on the marketplace. Then you have the trading where buyer purchases NFT directly. And then you have the royalties. And then lastly, that's optional where you can allow users to stake NFTs on the platform for more rewards, for example. That's just an optional workflow that I've included in case you want to build it. Now, I've included the architecture as well, in case you are coming from a very beginner background. But essentially, feel free to use any architecture you want. But this is just what I thought of from my point of view. So for front end, you can use Next.js or React with some sort of Tailwind CSS for the responsiveness of the UI, and some features could include user authentication, the video upload payback, the NFT minting, the social engagement tools. And you can also have some sort of, create a profile page showing the NFT minted and the earn rewards. And for the backend, you can probably use like Node.js. This is where you can, handle user interactions, where you upload, where the video is uploaded and the NFT metadata is processed. And then within the backend itself, you can use Gelato Relay to gaslessly mint the NFT once the video is uploaded. And if you want, you can possibly spin up automation tasks as well for, let's say, royalty distribution, for example. So these automations can be done via Web3 functions. I'll be also giving you some sort of background about how this works as well later down the slide. And obviously, lastly, the architecture for this idea includes the ABC public testnet, where you have to deploy your smart contracts. Obviously, you can deploy a smart contract for NFT minting, the marketplace, as well as the creator royalties, so for revenue sharing. And for ITFS integration, you can use Web3.storage or NFT.storage, as I mentioned earlier. So that was, I think, the gist of idea one. I think that was pretty straightforward. The next idea that we had was creating an AI-powered DEX on the ABC stack, on the ABC public testnet. And this is where I think the ELIZA OS, the ELIZA AI agent, the framework itself can come into play. And the concept here is also pretty simple. So essentially, you build a decentralized exchange at DEX where users can trade tokens. And essentially, you have these AI agents making smarter decisions and essentially making more efficient trades. And so within this combines the simplicity of the token swapping with the AI ability to analyze the market conditions and automating tasks like identifying undervalued tokens or optimizing trade strategies. So that's just like the concept of the second idea. And the core features include building a basic DEX. So that's something that you would have to build. Something that, it could be as simple as building a token swap. Like if you understand Uniswap, then you can obviously use their contracts as well for inspiration. But users can essentially swap their tokens directly using an automated market maker. And token pairs are managed in liquidity pools. And for the AI agent integration, the agent itself should be able to analyze the market conditions, the pool reserve, and identify the undervalued tokens. And it should be able to automate swaps based on predefined strategies. Then you obviously have the liquidity pool management, where users can provide liquidity and earn trading fees. And liquidity providers receive LP tokens. So that's like the regular case for their share in the pool. Then you have the real-time pool stats, where you can display the key metrics, the TVL, the swap, and the token price. And then we have the alerts, which could also be triggered by the agent or the Web3 function itself, where the agent triggers the trade when specific conditions are met. Or also, you can actually just show some sort of notification on the UI as well, that the agent has detected that the current value of token A, for example, is not right, so swap it for token B. So yeah, this is the end-to-end workflow as well. So you should have the workflow of the liquidity provision. So users provide liquidity to the tokens paid, so token A, token B, and liquidity is added to the pool, and the LP tokens are issued. Then we have the pool stats, where the agent monitors the pool reserve, the swaps. Then, like I mentioned, there could be some sort of recommendation on the UI as well, right? So suggestions for optimal trades, like token A is undervalued, consider swapping for token B. Then you have the trading, where users can trade via the UI, and you can basically get some insights from the agent itself. And lastly, you have the automation, where users can set conditions for automated swap, and then the agent will act on behalf of the end user. Again, so this architecture is you don't really have to use it. It's just something that I think, but I think it's a good place for you to get started if you're coming from a very beginner background. But yeah, for front end, you can use Next.js and React. I think that's like super standard now. But if you want to use something else, you can feel free to use that as well. So the features of the front end would include, let's say, token swap, some pool stats. Obviously, you have the AI agent recommendation, and then lastly, the automation setup. For the backend, you can use Node.js with Express. Then some features would include process the AI agent recommendation with the blockchain, so with the public testnet, then route the user's request to the public testnet, and then manage user profile, trade history, and maybe some API integrations that you can do to your front end. Then obviously you have the AI agent as well, which is ELIZA OS, which is a TypeScript-based framework. or you can use any other framework that you want, but that would also mean that you would have to somehow integrate some sort of automation. I'm not so sure, but I have experience with ELAS-OS. It's a TypeScript-based framework. Essentially, with this framework, you can analyze the pool reserves, the token prices, and the trading volume. You can identify arbitrage opportunities, for example. There are multiple use cases that you can implement. Obviously, it's up to you. These are just some of the examples that I'm suggesting in the slide. And lastly, you can use obviously the blockchain for deploying your smart contract. Let's say you have the automated market maker logic for token swaps, you have the liquidity pools, and then you have the reward distribution for the liquidity providers. Cool. I think that was the gist of both the ideas. I think that should be pretty clear. But if you have any questions, please feel free to ask them me after this presentation, or maybe if you have some time at the end, maybe we can take a look. But right now, I'll be walking you over on how you can connect to the ABC. So now we're going to get a little bit technical, a little bit hands-on. So yeah. So basically, if you want to connect to the ABC testnet, we have the UI. I'll be also showing this to you on the browser itself. This is how it looks. You should be able to see the RPC. You should be able to see the block explorer. You should be able to see the environment, the framework, the DA layer, which is Celestia, the chain ID, which is 112. And you can essentially just add it to your wallet just by clicking over here and get some testnet tokens by heading over to the faucet. So yeah, connecting to you can also add this to your MetaMask wallet or any wallet of your choice by just heading over to the block explorer or the link, which is let me just open it up real quick. So yeah, which is just ras.gelato.network public ABC testnet. Maybe I can paste this in the chat right now so you can just quickly take a look at it. Cool. And yeah, you should be able to add this to your wallet. You can access RPCs, both HTTP and WebSockets, and have a look at the faucet as well. And essentially, the faucet is just as simple. There's no requirement for the ETH mainnet in your wallet. Just enter your address, and you should get some testnet tokens right away. It shouldn't take that long, maybe like a couple seconds or so. So yeah, as you can see, I got a few testnet tokens, 10 tests for testing out. So that's how you connect. Next, we have the smart contracts. You can deploy Solidity smart contracts. This is a very simple example of a video NFT, but you should be able to deploy these smart contracts super easily. I deployed using Hardhat. You can also use Foundry, but I've also prepared like a GitHub repo for you guys so that you can just use it and just download it, just fork it locally and just start building on it. So you can deploy using Hardhat, or you can also use Foundry. You can also check out Hardhat docs or Hardhat deploy in case you want to deploy smart contracts. It's a plugin. It essentially makes it easier for you to deploy contracts using Hardhat onto your chain. Cool. So yeah, now that we have covered up how you connect to a chain, we'll also have some sort of live coding session as well, where I'll show you how I implemented the repo. But yeah, let's just quickly walk over Relay as well. As I've been talking about it, maybe you might not know what Relay is. So Relay essentially allows gasless transactions. It also supports the ERC20 token as payments. And also it allows, it's essentially just like an API which allows you to relay transactions without having to hold native tokens, right? And basically there are two approaches to this, but for this hackathon, I think using the sponsoring method or the off-chain method, which is by one balance, where you can sponsor users gas using our gas sign, which is one balance. And pretty much you can do this via sponsored call and sponsored call ERC2771. Now, what sponsored call ERC2771 is where we manage the authentication for you, where we'll be able to decode the actual message sender in target contract. And sponsored call, essentially, it's a self-managed authentication on your end. So essentially, this is the permissionless method where you can just call the target contract directly. So that's the gist of Relay. And for Web3 functions, it allows you to react it's basically these are both automation tools, and Web3 functions also work with one balance. So all you do is just top it up with USDC, and it will essentially just pay for transactions on all across your networks. And how functions usually work is that you select your trigger, you define what to run, and it will just execute those transactions according to the conditions that you have set. So let's say that you can have these trigger types like time interval, the cron expression, blocks, or on-chain events. And essentially, based on these trigger types, you can trigger, let's say, a block of TypeScript code, which will be your off-chain logic to execute some sort of transaction on-chain to your target contract, right? So that's what functions are. There are multiple implementation paths over here as well. So how you want to trigger your run, what you want to run, and the task creation. So you can trigger using time, event, or block. You can also trigger, what to run. You can run TypeScript functions. You can run Solidity functions or transactions. You can also create these Web3 functions using the UI, SDK, or smart contracts. And lastly, obviously, you have to monitor and make sure that it works as expected using the UI, or using a target smart contract. Cool. So I would just like to explain dedicated message sender. So that's like it's a, I would say, FYI you would have to know in case you're using Web3 functions. So dedicated message sender is a proxy contract that will send the transaction to your target contract, and it's deployed using on the first task, which you create, and is owned by the wallet that you could deploy the task with. So essentially, it just adds a layer of security and control on who can execute these specific functions on a smart contract. So it's just an FYI. You should be able to see this in the Gelato app as well. Cool. So I think before jumping into this, maybe I would like to show you some code snippets which I prepared. So right, I'm currently using Hardhat, and I'll just like to show you quickly. I hope this is readable. I'd like to show you quickly the configurations that we have for adding a chain to the Hardhat config. So essentially, all you would have to do is ensure that you have added the ABC Testnet, which is including public URL, the private key, as well as the chain ID. And in case you would like to verify your smart contracts, etc., then ensure that you've added this into the custom chains and the Etherscan plugin as well. This will allow you to essentially verify your contracts. I've currently deployed a contract for one balance relay. So I'll be just quickly showing you an example for relay. Let me just open up this example. So let's go to Block Explorer. And then let's quickly see this contract. Cool. So as you can see, I've deployed this very simple ERC2771 context contract. This will allow me to relay transaction. Maybe I can just quickly show you my script, which I've written to implement to run this relay transaction. So I'm using the relay SDK to interact with this contract and to relay the transaction. I have some environmental variables that I need to load, which is the RPC URL, the private key, and the Gelato Relay API key, which you can get from the Gelato app itself. Let me just quickly show you how you can do that. So this is how the Gelato app looks like. I'm just going to give you a quick walkover. So you head over to app.gelato network. You head over to, you log in using your MetaMask wallet or wallet of your choice. You can head over to Relay. You can head over to Testnets and basically create a task there. Then we have the one balance, which is the gas tank, where essentially for testnet, you can top up Cipolla ETH. And basically, this will be used to sponsor transactions for all the networks that we support. And for Web3 functions, the good thing is that we actually sponsor 0.5 Cipolla ETH per day. So yeah, that's like a perk that you get for Web3 functions. Cool. So so jumping back into the code. So we initialize the provider. Then we initialize the Gelato relay object. Then I have my contract address and the contract API. I would like to call the increment function. Quickly, I'll just walk you over what this contract really does. So essentially, I have this function called increment, and it will just increment the counter, and it will basically store the message.sender and increment the counter by 1. So it maps the address to the counter value itself. Cool. Then, yeah, I prepared the contract details, and then I get prepared to make a sponsor call, ERC2771. I have the user, the chain ID, I have the target payload, and then I create a call with ERC2771 request where I pass in the chain ID, the contract address, the data, and the user. And then I send the request for the sponsored call. So then we have request, signer, and Gelato passing along the Gelato Relay API key. And then I should be able to get a task ID. Maybe I can run this real quick again. As you can see, I've already run it. I have a task ID over here, but maybe we can give this a shot again. Let's see if we get. Cool. So here is the task ID. Maybe I can open this up real quickly. Cool. And then I'll just paste this in over here. Cool. So I think that was an exec success, which means that the transaction went through. We can also quickly check this by heading over to the contract, heading over to read, and getting the counter of my wallet address, which is this one. This should ideally be 2 because I already ran a script before, so 2, which is correct. So yeah, that's just the gist of running the sponsored call, relay transaction, ERC2771. I'm not sure, but I think the time for Web3 function is low, but maybe I can just give you a quick overview of the UI itself for running Web3 function. Essentially, you can just create a task. So as I mentioned, you have trigger types, you have the time interval, cron, on-chain, and every block. And you can select the time. Let's say I want to run this every 5 minutes. And then I can essentially select a TypeScript function. And basically, this TypeScript code is published to IPFS. So there's a template for it as well for you to publish your TypeScript code, which I'll be sharing that as well in the chat as well shortly. And then essentially we just public that IPFS CID, configure it on the chain itself, and then just run it. And this should run according to your configuration. So that's Web3 function in a gist as well. I think this should give you a good idea of how you can use these automation and these suite of middleware services. You can also use VRF for fetching randomness, but I think that's beyond the scope of this. But I can share docs, and also I can help you guys answer some questions if you guys have any regarding VRF as well. Now, the cool thing about agents is ELIZA OS. Maybe I can just quickly show you how this looks like. So basically, over the weekend, I prepared this plugin, which is the plugin for Relay, where this will allow you to send out transactions using Gelato Relay, sponsored call, and sponsored call 2771. The code is pretty hefty. You can also take a look in the actual repo itself, ELIZA OS. It's open source. But I think the main action is that the main thing that you need to know is the action itself. So when you create a contract interact action, this will basically find out the prompt that you give, and this will essentially be able to figure out that if it's a sponsored call or if it's a sponsored call 2771, and then this sends out the transaction accordingly to the testnet of your choice. You should be able to add the public testnet as well, because within the wallet, you have this function called add chain. And this will actually, let me just zoom this in for you guys as well. And this should essentially allow you to add like a custom chain within the plugin itself. So this should also allow you to interact with the public testnet chain. So yeah, let me just quickly show you guys some screenshot of what I was able to do. So there's this UI that you get when you work with the ELIZA OS framework, when you spin it up. And essentially, you can just chat with it like ChatGPT. And I pretty much asked it to increment a similar example of what I just did, but using the ChatGPT UI. And I asked it to do the sponsored call request for me, given all the data, and was essentially able to do it with the successful interaction. And I was able to get a task ID easily. And as you can see that I was using the OpenAI model for the large language model, and I was able to get the task ID. And yeah, this is just like the power of what you can do with the agents as well. So yeah, feel free to, go nuts with it, and yeah, just use it for the use case. I think this could also be implemented on both the ideas. But yeah, however you want to use it, I would love to see how you guys implement that. I think that pretty much sums up. I think we are right on time. So yeah, lastly, I would just like to say happy hacking. Yeah, I know it's gonna learn a lot.